So hello everyone, welcome to this new video. So in this video, we are going to discuss with the embedded firmware development languages. Okay, so which and all are the firmware development languages which are used in the embedded systems? Those things we are going to discuss in this video, and the conversion of languages based on the requirement, that also we are going to discuss with one block diagram. Okay, so let us see that now. For embedded firmware development, we can use either a target processor controller specific language, generally known as assembly language or low language, or a target processor or controller independent language like C, C++, Java, etc., which is commonly called as high level language. Okay, so these are some of the high level languages which the target processor or controller uses, that is the C, C++, Java, which is commonly used, and those languages are called as high level language. A combination of assembly and high level language would be very essential for the embedded firmware development languages. Okay, so now let us discuss with the assembly level language based development. Okay, how the conversion taking place. So the assembly language is the human readable notation of the machine language. So the machine language is a processor understandable language. Okay, that is the uh, assembly language is simply the human readable. If you want to convert that human readable so that the system would be understanding it, we should be converting it to the machine language. Okay, so that machine language is a processor understandable language. Machine language is a binary representation and it consists of ones and zeros. Okay, machine language is made readable by using specific symbols, and these symbols are called as mnemonics. Hence the machine language can be considered as an interface between processor and programmer. And assembly language and machine languages are processor controller dependent, and assembly program written for one processor controller family will not work with others. Okay, so this sentence means that one assembly language and machine languages used by any microprocessor or any microcontroller, they are only dependent on the specific task related programs. Okay, so that the embedded system would be performing well, that conversion between assembly and machine level language should not be splitted with any other embedded devices. Okay, it should be specific, it should be domain specific, it should be domain oriented, and it should not have any other characteristics based on the different parts of the devices. Okay, assembly language programming is the task of writing processor specific machine code in mnemonic form, converting the mnemonics into actual processor instruction. Okay, so and it is associated by the data using an assembler. Assembly language program was the most common type of programming adapted in the beginning of the software revolution. Okay, so this program is the was the in earlier days it was the most common used program. Okay, which was very essential for the revolution of the software in the modern day. Okay, even today, also almost the low level system related programming is carried out using the assembly language. In particular, assembly language is often used in writing the low level interaction between the operating system and the hardware, for instance, in the device drivers. Okay, the general format of an assembly language instruction is an opcode followed by the operands. The opcode tells the processor or the controller what to do, and the operands provide the data and information required to perform the action specified by the opcode. So these things, opcodes, operands, and all you have discussed in the fourth sem microcontrollers, right? Also, the ARM processor, that is in the fourth module, we are going to come in this embedded system only, and that also we are going to discuss with the opcodes and operands. Okay. So this was about the complete assembly language based development. Okay, so these are the some instruction sets they have used. Okay, so these things are all you have already done in the microcontroller. The assembly language program written in assembly code is saved as .asm, that is the assembly file, or .src, that is the source file. Okay, also .s file, and any text editor like Notepad or WordPad from Microsoft, or the text editor provided by the integrated development IDE tool can be used for writing the assembly instructions. Similar to C and other high level language programming, we can have multiple source files called modules in assembly language programming. Okay, each module is represented by the .asm or the .source file, that is the assembly file or source file. This approach is called as modular programming. The modular programming is employed when the program is too complex or too big. Okay, so this modular programming approach is for the programs which are complex. Okay, In modular programming, the entire code is divided into sub-modules and each module is made by reusable things. Okay. The modular programs are usually easy to code and easy to debug and alter as well. Okay. So this you see here one block diagram which is very essential. This is the source file to object file translation. Okay, so this is very important, guys. The translation of assembly code to machine code is performed by assembler. The assemblers for different target processors are different. A51 is used for macro assembler for from Keel software, which is popular assembler from the 8051 family microcontroller. Okay, so this A51, the various steps involved in the conversion of a program written in assembly language to the corresponding binary file or machine language is illustrated here. The conversion of assembly level language to machine language. That is where we have library files, then we have object file, different object files. For different object files, we have different module assemblers. Okay, source files is given to the object files and they are given directly to the library files. Okay, so this is the object to hex file converter which converts the binary code to the hexadecimal code which is required in the ARM processor or the microcontroller. Okay, so this block diagram you note it down, very important one. Okay, so yeah, that's all, guys. So this was all about the conversion of assembly language to machine language. In detail we have discussed with the assembly language based development also. So yeah, so this comes to the end of the module. Before that, we have one few differences to be noted down. Okay, from the exam point of view, these two differences are very important. Okay, one is the difference between C versus embedded C, and one more is the difference between compiler versus cross compiler. Okay, so these two differences are very important because these two differences are mentioned in the model paper as well. So that's why I thought to do this. Okay, so the difference between C and embedded C, let us see now. If you come to the C language, C is a well structured, well defined, and standardized general purpose programming language with extensive bit manipulation support, whereas embedded C can be considered as a subset of conventional C language. So C offers a combination of the features of high level language and assembly level language and helps in hardware access programming, that is the system level programming, that is whatever the system is desirable to program. In the same way the C also offers the combination of the features with respect to the program itself. Okay, as well as the business package developments, that is application developments, whereas the embedded C supports all the C instructions and incorporates a few target processor specific functions. Okay, so one change in the embedded C is that it is since embedded systems are application and domain specific in nature, so that's why the embedded C supports all the instructions, but it is domain specific. It provides the set of instruction which is required for that application only. Okay, the conventional C language follows the ANSI standard and it incorporates various library files for a different operating system. The standard ANSI C library implementation is always tailored in the target processor or controller library files in the embedded C. A platform operating system specific application known as compiler is used for the conversion of programs written in C to the target processor on which the OS is running specific binary files. Okay, hence this platform is specific development. The implementation of target processor or controller in the specific function instruction depends upon the processor or controller requirements as well as supported by the cross compiler. Okay, so these are the few differences between C and embedded C. Okay, so please note it down. These things are very important. So this would be available in this notes only. Okay, at the last page of the notes we have these two differences. Okay, C versus embedded C, compiler versus cross compiler. Okay, so these are the differences of compiler and cross compiler here. So I'm just going to read out two differences here. That is, a compiler is a software tool that converts a source code written in high level language on top of a particular operating system running on a specific target processor architecture. Whereas cross compilers are the software tools used in cross platform development application. That is, in cross platform development, the compiler running on the particular target processor or the operating system converts the source code to machine code. We have seen earlier, right? It converts the source code, that is the assembly language, to the machine code. That deals with these cross compilers. Okay, here the operating system, the compiler program and the application making use of the source code run on the same target processor, whereas in cross compiler since it is a cross platform development, the target processor would be varying. Okay, so these are the few differences here. Some 4 to 5 points are mentioned in each column. So please read it and study it. Okay, so that's all, guys. These are the things which I wanted to discuss to you all. Just this is C versus embedded C. Please take a screenshot and read it. Again, compiler versus cross compiler. Take the screenshot and read it. Okay. These two questions are there in the model paper, so that's why I thought to cover it. So please go through it. Okay. So that's all for the video, guys. We have covered with the entire module 2, which is there in your syllabus, the of the embedded system design. Hope everything is covered and hope you understood something from this module. And please listen to the videos, guys, because these videos are very important with the exam point of view, and these videos are very very important because these from these videos only the questions will be arriving for the exam. Okay, so in a short amount of time I'm going to provide the model paper solutions as well, so stay tuned for that. And keep supporting us, guys. We'll see you in the upcoming videos with the module 3 of the embedded system. Thank you.